Find the approximate x-intercept and approximate y-intercept of the graph of the equation. So this is our equation, and our graph, I don't know exactly how our graph is going to look like, but it might cross the x and y axis, and where it crosses the x-axis is the intercept. And let's hypothetically say this graph goes like this, maybe. This would be the x-intercept where it crosses the x-axis, and what we can say about that is that y is equal to 0 on the y-axis. So that's how we're going to approach this. We're going to set y equal to 0, and we also should know that y is equal to f of x. By setting y equal to 0, we have 0 is equal to 2.42x minus 56.12, and we'll add 56.12 to both sides, and then we will divide by 2.42 on both sides. And so x equals, now I guess for this I'd want to use my calculator and find out what 56.12 divided by 2.42 is equal to. So now let's round off to 2 decimal places. I'll call this 23.19. So that's the x-intercept. The y-intercept, for some cases, is a little bit easier. I mean, the calculations might be a little bit easier. If we go through the same thought process, the y-intercept is where it crosses the y-axis, and where it crosses the y-axis would be a point where x is equal to 0. So that's what we'll do. The f of x again is equal to y, so we'll treat this as y is equal to 2.42 times x minus 56.12. Now instead of x, we're going to put 0 in for x, and then we'll see that y is equal to negative 56.12. That's the y-intercept. So if we were to graph this, we weren't asked to graph it, but if we were to graph it, I would graph it like this. I know I have 2 points. I have my x-intercept at 23.19, and that would be 23.19 comma 0. My y-intercept is negative. That's why I kind of drew more room on the negative side. And that would be an x of 0 and a y of negative 56.12. And then the line would simply go through those 2 points. Alright, so that's the x and y intercepts.